Hello everybody. Welcome to Devoxx. I guess today is the first official day, though a lot of you have been here for a while. So my name is Joe Nuxoll. Probably a bunch of you remember me from the Java Posse, though I left the Java Posse quite a while ago. And I actually haven't written code for many years. I'm supposed to hear a boo for that, right? No. All right. Yes, good. But I have written lots of code, so I'm eligible to speak at Devoxx. Right now, I'm an independent user interface designer, consultant. I work at a lot of different companies, but I was at Tesla for a very important period of time designing the Tesla Model S touchscreen, the user interface for the touchscreen and the mobile application. Last night at the speakers dinner, I bumped into Stefan and said, "Hey, I'm here. Anything you want me to do?" And he said, "Actually, one of our speakers missed his flight. So do you have anything you can talk about Tesla?" And I'm like, "Well, yeah, I could probably come up with something." So I'm just going to go through a slide deck that I use when I'm talking about the design of the touchscreen. How many people in here, though it's hard for me to see, how many people in here have been in or driven a Tesla Model S? Cool. How many people own them? I know there's at least one. Carl's got one. Cool. It's a pretty cool car. I'm extremely biased, as you might expect, but I also believe that if you take this touchscreen that I worked on and rip it out of the dashboard and throw it out the window, in my opinion, it's still the best car ever made. So it's a pretty amazing car. The touchscreen's pretty cool too. So if you're not familiar, the Model S is unique in that it's, from my understanding, it's the first car that doesn't have any tactile knobs or anything in the car. It's got a 17-inch touchscreen for all the controls, HVAC and nav and door locks and windows and all that sort of stuff is all done. Actually, the windows are tactile controls on the door, excuse me. But all of those things that are normally a huge array of knobs and dials and things on the dashboard just don't exist. It's a touchscreen, which means it can be updated over the air with software. And they're already up on version 6.0. It was a heck of a challenge. When I came into Tesla, they had started on the project, though it was pretty nascent, and the majority of it hadn't been designed. It was just sort of a whiteboard like, okay, well, we got to do stuff here. So it was a very exciting challenge. The first step was to go and research what the industry's doing. Big surprise. You can't really rent a lot of these really high-end cars that we were targeting, so we actually bought a whole bunch of cars. It was pretty cool. So I got each one of them for a day or two, some of them for longer, set up a little camera and drove the car around and just used everything in it while I was driving and while I was parked and sort of inventoried the current state of the art of the industry in all the high-end cars that we were going to be competing against. This one I think is a Mercedes. Oh, so it's a Jaguar. Thank you, Dick Wall. Actually, a really cool feature came out of, was inspired by this car. This one, it's hard for me to see this screen. Anybody see a logo? I think it's Porsche-esque. It might be a Mercedes. This one is a Porsche Cayenne or Panamera. They actually have the same interior piece. This is my, at the time, Nissan Pathfinder with an aftermarket deck, which I thought was pretty good. And then this was my favorite. At the time, the Audi A7 has a really cool Google Earth 3D flyover map thing integrated into it. So I got to drive all these cars quite a bit and inventory what their features were and all the functions of the car itself. So there were times where I would tilt it down, and in my little videos I would go through and describe what all the different controls did and how they changed. Actually, this one was kind of cool. This is in the Porsches. This is a touchpad that actually has LED backlighting, and it changes from a number pad into an actual pad you can write on, depending on what function was in the front on the application itself. So that was pretty cool. But look at all these silly knobs and dials. Should all be in a touchscreen. So one of the first steps, and this is too tight to read, but that's probably a good thing. This was the early omnigraphal of here's all the functions we probably want. Some of these things are highlighted to show that we need this functionality surfaced in the mobile application. Lots of different subsystems and things, but this was sort of my mental model of this is what I would like in the car based on the research and based on looking at pads and all sorts of different UIs. This is my idea of what the ideal sort of car UI would contain. And then we just started working through boxes. So the interaction model was one of the first things we had to tackle. You see on the left, and a lot of the, I don't know, you won't be able to see in the video, but I'm pointing with my laser pointer on the left side. Any cats in the room? I don't see any cats. Start sprinting at the thing up here. Try to control yourself. The stuff in gray here, these are the wireframes. So my job is user experience, basically laying out what should it do, how should it function. And then I had a couple of people I was working with, really, really, really good visual designers. All of us had come from Apple, so it was a nice sort of synergy of at least similar ways of thinking about UI. On the right is the post-visual design for a lot of these things. The way we set it up was along the top was a static region where your primary functions are. You could have two different apps running at a given time in these two sort of panes. And on the bottom, we had another piece of static real estate, which is sort of using, it materially looks like it was part of the car. So that stuff never changes, is always there regardless of what app's there, whether it's maximize, minimize, etc. So this really feels to the user like their physical controls, and they were skeuomorphism, which is the term meaning they look physically like real things with shadows and stuff. Move forward one. You could also expand a single app into the full size of the screen, and so the thing would pop open. So you could either have two things running or a single one running, and by clicking in that bottom corner, you popped it open and closed. So one of the first exercises, aside from the looking at the rest of the industry and what they're doing and making a map of all the features we need, we wanted to figure out what's a good user interaction model. So part of that process is going through lots of wireframes. And let me back up one click and say that all these presentations, these are the actual wireframes. I mean, these are literally them just stuck into a keynote presentation. We had on our desk in the design team, we had an actual screen from the Model S, just sort of to the right of our regular design monitors, connected to a Mac Mini with a custom driver board, so it was just a regular display. So our design work, before we would put it in the car, we would have on this display where you would just sit at the desk and sort of visualize that you're in the car, and you would tap the keyboard to move through these screens as if you were just doing like a flipbook animation. So usually the first iteration of these things were all just sit down, pretend you're driving a car, and play with it. Later in the process, we had an app that we ran on the car that let us take the whole screen over with screenshots. And you would just tap on the screen in the car for it to move forward. So you could be driving and think about like reach distances and all those things. So here's an alternative interaction model that we played with, where instead of a bar across the top that showed all your primary apps, we had this notion of an app button. And on the physical car, there's only two buttons. Just to the left of the screen, there's a button here that is the hazard lights. The NTSB, at least in the United States, requires a physical button for hazard lights, which makes good sense. And to the right, there's a button that electronically opens the glove box. We had a bit of a debate with the vehicle team to try to use this space for an app button, kind of like an iPad sort of home button, but we lost that battle. So in this iteration of the design, we had the app as still a digital button sitting on the edge. When you tap that, in 3D space, the applications would fade out and sort of roll into the background, and a series of icons would appear and show that, you know, maps is happening up here and media is happening down here, and you could tap on these things in order to replace one of those apps. And when it's in full screen, or when an app is in full screen, instead of the two sliding apart, it just faded into the background and the different apps overlaid. This is another version of the interaction model that we played with, where instead of a central app button, we had these as independent regions. So you could tap, actually, let's go back. You could say, I'm going to tap right here, and it pops open sort of a carousel of all the apps that you could replace that with, and you could scroll through it and tap on one, and it would replace that app with that. If it's in full screen, same sort of thing. You would tap, and it would be, which app do you want, and click on it. From a user experience perspective, this allows more real estate to the app you're actually focusing on, but it reduces discoverability in that you don't necessarily know which apps are available, and you don't even know that you can necessarily change apps. So here's one more version of this interaction model where we have two different screens and they're independent, and if I tap on the apps button, then that app would just show that it's currently running music, but any one of these other things is available. And if you tap on that thing, it just replaces it. And you can do the same on the top, and even while you're mucking with the top one, you can tap the bottom one and separately muck with that one. So this is the independent interaction model. You just treat them as two independent spaces. Click on music, click on energy, and now those two apps are running. Now if you click on the maximize button or the make bigger button, it would just take over the whole space, and then that same app switching interaction would take over that whole space. So click on web, it switches to web. So that's just an example of the process. We went through a whole bunch of these, and this is sort of a sample of one of them. And where we ended, if you're familiar with the Model S, is the one I started with, which is the layer of buttons across the very top that shows you all the apps that are available. Hi there, how you doing? Right. So the next piece is navigation. These are the original sort of prototype wireframes for the Nav System in the Model S, which is sort of an amalgamation of the iPad Maps system, which eventually migrated to the Google Maps system on a pad, and a lot of the things you see in many of the different cars. I'll warn you, some of the stuff in here isn't in the car yet, so if anybody's driving a Model S and says, hey, I saw a thing that's not there, I don't work at Tesla anymore, so it's either coming or it got cut. I honestly don't know. I could probably find out, but I'd rather just be surprised. And I should say, I left Tesla almost 2 years ago now, and the first feature just got launched in version 6.0 that I had never heard of or seen before, which is the calendar integration with your phone. And I was really excited because it was, you know, we had designed so much stuff that takes time to roll and get done. That was the first feature that appeared that I had never heard of, and I was pretty excited. So the Nav System. For wireframe purposes, we had it in full screen mode, but you basically are sitting there, you have a nice satellite or just map view, and you tap on a search button, and it pops up a thing that lets you search a variety of different ways. So we have this notion of categories. So if you wanted to do a quick search and not have to type anything, you could just click on the search button, click on restaurants, click on Italian, and it's filling out categories on the top. And then you could start typing, and it did a lot of smart stuff here, where it knew what your favorites were. So if you start typing something that is a match that it knows is an Italian restaurant in your favorites, that would be the top item. And then it's searching using an online, basically a Google Places kind of thing, to figure out Italian restaurants within the region of that map. So stuff that is very common now on like iPads and things. But this is why you're driving in your car. Another option is favorites. You could store both specific locations or searches. So if you just like frozen yogurt, you could be driving along and go search for favorites, frozen yogurt, and it would drop a bunch of pins for frozen yogurt places near where your car is now. Or you could just start typing and it would do a match across all these categories, across searches in local areas, etc. Or if you typed a specific address, it would know that that matched a particular location in your favorites. Another one, and this one actually came from the Jaguar. Hopefully I said that right. This is the Get Out of Compton tab, where it detects nearby freeway on-ramps. So if you're in the middle of some city and you want to get out of there, you click on freeways and just say, I want to go north on 280. And so the nav would do all of its work until you were northbound on that freeway and just turn off. So you don't have to choose a destination. You just say, I want to go north on that freeway. This, to my knowledge, is not in the car yet, or won't be in the car. I don't know. And then contacts. If you have a phone connected to the car, it goes into your contacts and finds any contacts that have an address associated with them. So you can just, from the Nav app, go and click on somebody's address and go to their house. This example, I'm looking at Joe's iPhone, which is one of the devices connected, and I click on a person, and if it has multiple addresses, then you click on that one. And then in your history, it shows not only specific searches you did, but also specific locations you've been to, etc. And this notion of always showing generally what direction it is according to the map and roughly the distance to that thing. So it's running a lot of nav algorithms at the same time just when you're browsing this list. So once you pick a particular place, pops up a thing to either automatically nav to it, or you can call it or look at their website. All the different apps are talking to each other. And if you search for a non-specific place, like restaurants, it then shows a list. And this is very similar to what you see on the iPad. And you could click on any one of those on the left, or you could click on the different pins, and it would pop up and say, do you want to nav, call, or look at their website? And once you're navigating, it collapses the nav into just a set of directions. The current direction, the next one, maybe a couple of these. We play with iterations of this. And then always, how far do you have left to go? How many minutes? And what is your arrival time going to be? Always, recalculating as you go. It also shows a current address of where you are, or a range. So it's doing a sort of a GPS reverse lookup all the time for where am I right now? What range of addresses is this on this street? And you can tap the arrow to bring you back to where the car is if you've scrolled away on the map, or you can click on the checker to zoom the map to your final destination. So if you wanted to look for frozen yogurt near your destination, you would click on Final Destination and then search for frozen yogurt. And while you're already navigating, you can still go into the whole search operation, and it's exactly the same. Nothing changes just because you're navigating. It just allows you to go search for stuff either right where the car is, or near your destination, or anywhere you've scrolled or zoomed the map to, as you would expect. And when you want to nav there, do you want to replace the destination? Do you want to insert it before, insert it after? All the stuff you would expect in a nav system. And then off you go. If you click on details, it then shows you these are all the different steps in the directions. And this is the first destination, which you can delete if you want to, and continue to vertically scroll this thing. So this is some of the screens from the original wireframes for what we wanted to build. And is there one more? Oh, there is, yeah. So little context menu things for switching to different views. Oh, and then the map version that doesn't have satellite data. Okay, and then now, this is after many, many iterations and lots of testing things in the car, we came down to this. This is the last set of wireframes before we went to pure visual design, where you have the maps up, and this notion of typing ahead, we kept getting feedback from the people playing with the cars that they wanted to get straight to typing something like they're used to doing on Google, essentially, Google Maps. So we put that right front and center. So you could just tap and start typing. You get a keyboard come up on the bottom. And as you typed, a lot of that search functionality was built straight in there. And the browse had the other types of functions. And same stuff. So this is the higher fidelity wireframes, which we sort of go through many different versions of wireframes before we get to visual design. So another process. Again, this is the work of UX. Most of you guys, let me back up a second. Anybody here do a user interface design as a profession? Just a couple, cool. Anybody forced to do that because you don't have a user interface design group? I'm expecting a lot of hands. Okay. Some of the bigger companies, obviously Apple and Tesla, there's separate teams that do the design and the thinking around that and the playing with that. Lots of interaction with engineering to make sure we're designing things that are possible. Helps to have been an engineer formerly. But then there's a huge process to build this stuff, as you guys know. So this is another thing where we have this notion in the car that's used many places. It's a two-column view that can go deeper and deeper. It could be like 8 columns wide. And we wanted to come up with a simple way of navigating across the depth of a tree in here. So this is an example, or I should say the prototype wireframe set. This is the actual ones we used. And this is the one that won in terms of how it works in the Model S now. So if I have currently, like the thing we're looking at is this multi-column browser. So right now I'm looking at radio, and I click on FM, and that right-hand list swaps to the list of FM things. It shows a scroll bar temporarily, and then that scroll bar fades away, just to indicate, hey, there's more content. We also use intentional clipping. So we set up based on the piece of real estate we have. It's very important in a touch UI to have the last item partially clipped. So you don't need to show a scroll bar all the time. This is sort of the current touchscreen metaphor you use, where you show that there's another item there. Like if there was an icon, you'd see that icon cut off or whatever. Or if there's like a gradient on this, you could very clearly see it was cut off. So people know that they can just naturally scroll and swing that thing. And if I go to devices and click on Joe's iPhone 5, this is back when it was like iPhone 3G or something, I think. I always have the name of my phone is usually one number ahead just for fun, just to freak people out that got in the cars. Scroll bar appears and then disappears. And when you tap on a drill in, notice at the bottom of the screen, a piece of real estate slides up that shows a couple of bars. This is really showing the view pane. Right now you're seeing these 2 columns out of a total of 3. So there's a hidden column that's 1 level down. Scroll bars appear and then fade out. And in this example, we actually have an alphabetical list that has a zoom ahead with letters. So if I click on U and then click on U2, we now drill a level further and this thing has grown. The user can tap here to get back to the beginning, etc., or tap or physically click and drag across and move this set of columns. If they click on Van Halen, they then have obviously the list of Van Halen songs. They click on 1984, great album. It now scrolls, and now it's a 5-column, or I should say a 5-level deep tree that they're looking at, and they can only see the last 2 items in the tree. Scroll bars disappear, and now they tap on the second item, and the whole tree scrolls over, and you can see sort of the viewport scroll over. But the selection state is maintained, so now you're still 5 levels down, but you're just viewing the number 2 and 3 slot in that tree. But if you tap somewhere else, like on songs, you've now just clipped the bottom of the tree in terms of your selection path. So the bottom animates to show that now the tree is only 3 items deep and you're looking at the bottom 2. So stuff like that. This is the life of a UX designer. You go through all these iterations, and then you have the engineers build it, and you go try it in the car and see how it feels, adjust hit zones, and I mean that's what we do. We do a lot of it. So clicking on favorites, clicking on stations, these are a lot of just things we were playing with at the time. Like how when you delete an item, instead of just having it go away, you might accidentally tap that X. So we had a delete button appear, and then you could tap on that, and it would animate and disappear. Show the new scroll bar size, and then have that fade out. Search, we were playing with a lot of different ways of dealing with search. Here's a search that is across all the tabs. And then here is a search that is context specific to the current tab you're in. So you type Coldplay, and it categorizes them based on which tab is active. So all these considerations, you can just invent stuff and try it out, or you can go research what's out there. I mean, there's millions of ways of doing it, but this is the life of a UX designer. So now we get into some of the more meaty bits of the Model S. Again, the left side, this is the actual wireframe, the original stuff, several iterations in, and then this is the visual design version of that, where we did real 3D renders of the car. Actually, in the car, it's kind of cool. This matches your car, matches the color of your car, the wheels, the options, like all that stuff. And even down here, when you turn lights and things on and off in the car, even the turn signals, this whole thing matches what's really happening. Of course, if you hit a deer, the deer does not show up here. We are trying to do that now. But some just interesting things in terms of UX. This idea where we wanted to show a physical representation of the car and just adjusting where the sunroof is sitting. We know we wanted to have it be something very tactile. You could click and drag along the car. But if you didn't have this control next to it, you wouldn't necessarily know that this is something you can click on and drag. So we made sure that in alignment with the vehicle, there's so many iterations of this stuff, it had to be very obvious that this graphic supports this control. And you may not even know until you've had the car for a while that clicking and dragging this is exactly the same as clicking here and dragging the sunroof up and down, and this bar moves with it. Actually, let me go back to down here. Also, things with locks. We did so many different iterations for the locks controls, front trunk, or frunk is what we called it, because it's you guys know that the motor in the Model S is this little thing about the size of a watermelon between the rear wheels. So the front trunk and the back trunk are both vast. There's nothing blocking them. So getting into the front trunk and getting into the rear trunk and locking and unlocking the doors and open the charge port, these are all things you need to do all the time. So we tied when you tap on the controls, by the way, in terms of reach, the most prime spot is the bottom left-hand corner from the driver's position. You also have the metal trim around the corner, that bottom, well, the whole thing, but that bottom left corner, people would, without even looking, would reach over and sort of use it as a physical reference and be able to tap that corner without looking. So if you need to like turn your lights on or unlock a door or something, you would just tap that and get this screen. And then regardless of which sub function you're using on this left side, all of the locks and lights controls are always visible down there. And this is many iterations before we got to this. Here's another one. So I've moved from sunroof down to driving controls. This controls the ride height of the car if the car has air suspension. So this is very similar to the sunroof thing where we had a fully rendered version of the car, and as you muck with the ride height, the image of the car actually moves, and it's sort of like a dotted move, and then as the thing's physically moving, you can see the car move to its actual spot. I should point that out, by the way. When you do this, when you drag, you get a dotted outline that shows the percentage, and then you let go, and then this animates to the position in one-to-one real time with the sunroof. So you see a dotted line, you let go, and then it starts moving, and it's actually really fun to play with. It's kind of mesmerizing. Same thing here though for suspension. And then a lot of just basic controls, and the whole debate with engineering about what should the settings be and what should they mean, and how much percentage difference is the steering inputs. That's a lot of the sort of fun stuff you deal with. And how do you simplify and group these controls so there are things that you don't have to think a lot to look at. Next one, trips and range. How many people actually use the trip counter in their vehicle, in their car? How many people use it for other than calculating fuel mileage? So, very few. So we decided, since this is an electric car, we may as well have the most common use of, I don't know if you guys can read this, but it's since last charge. It automatically does a trip based on your last charge to calculate your energy usage just without you doing anything. So we have found people rarely use trip meters for other stuff. So we still had them in there, but this automatic one is really the one people used. And then there's a lot of different visualizations and things we played with on what is based on the current state of charge of the battery, how far should you be able to go based on 55 mile an hour even driving. I guess it's just under 100 kilometers per hour. Versus how heavy is your foot. Because if you really slam an EV, it's a lot less range, and if you barely, if you sip on it, you can get massive range on the thing. So we had to represent both of those things, and we had a lot of iterations on how we do it. This is what's actually in the car. Another really fun one is playing with audio levels. This is something there is more precedent for. There's some decks that have pretty elaborate sets up for audio, but no one had done this before, which is just a touch control of a view at the top of the screen to set your balance and your fade just by tapping where you want it to be centered in the car. So that was a cool one. This is what it looks like in the car. Next one is the HomeLink. HomeLink, if you're not familiar with that, is the programmable garage door or gate opener thing that a lot of cars have in it. And we had the added advantage that ours was, it's a standard module that are in many cars, but we also had GPS in the car. We had the whole thing tied to this computer system on this UI. So instead of just having, position 1, 2, and 3 for your HomeLink, we were able to build this whole sort of virtual named entity on top of each one of those settings that's also tied to GPS. So you can create a HomeLink, give it a name, program your garage, and there's a whole bunch more screens to this, but just conceptually, it allows us to, when you programmed it, wherever GPS location you're in, we automatically built a fence, a GPS fence. So if you drive up to your driveway, a thing pops up and says, do you want to open your garage door? You don't have to, and you just say, yes, I do, and it opens. And they've now done the same thing with the air suspension. If you have like a really nasty driveway, there's a GPS fence around multiple times that you've adjusted that. It will just automatically say, hey, do you want to pop the suspension up because we're obviously coming up to your driveway. A lot of really helpful things when you tie all this stuff together. Another one is driver profiles. So how many people actually use more than one seat position storage on your car? you know, seat position 1, seat position 2. Anybody? Anybody? Couple? If you have this all tied together in a piece of software, you can do a heck of a lot more with that. So it's the same thing. It's the same hardware unit where it has X number of seat positions. It has the same recall and place function. But we encapsulated that in this notion of a named driver, a driver profile. So you can create a named driver, and it stores your radio presets, your phone preference, obviously your seat position and your mirror positions. All that stuff's all encapsulated in a driver. And you can also link that to a particular key. So this is the original, again, wireframes, and this is all the conceptual, like, hey, can we do this, engineering team? That went through the driver profiles, which is one I'm actually pretty excited about, because now that I've used it a bunch, I love it. I wish every car was this way. So first of all, again, this is an example of the flip deck, and imagine me sitting at my desk or having people like come in, sit down, play with this, and tell me what you think of it before we ever actually built it. So I sit down in the car, and no driver profiles have been set up, but there's this little dude up top. If you tap on that guy, it pops open, and it shows that you can save your seating position if you want to. You can also click on Create a Driver Profile. If you click on Save, then it just saves. So it has this notion of one unnamed driver profile, which is the same as like a seat position 1 that you can save or restore. The minute you move your seat at all, it triggers that, okay, it's changed. Just like you get an asterisk in an editor title when the file just gets a new character or something in it. You guys can relate to that, right? And the minute you click on, I want to restore, you can obviously save the new seat position. If you want to restore to go back to the saved one, it turns into a stop button, which we had to do. We learned later we had to do because you could have like a 2-foot-tall person that has a seat position saved and a big person's in the car. You have this pinch problem. And the electric stepper motors don't necessarily detect that they're crushing flesh. So you need a real obvious stop button. Now, if you have a named driver, up there it says Joe next to the name, and I should also point out this top bar is also a piece of static content that's always there. It's a status bar. So it always has the temperature, the state of charge, what sort of network service or Bluetooth status, and the time. And I don't know if you can see it here, but it has all the mechanisms for showing if the passenger airbag is on or off. All these NTSB things we had to deal with. So now if you tap on the driver, you can, if you haven't added a new driver, it just is a save and restore. If you do have drivers, then there's this notion of different drivers in a list. You can just tap on the driver name, and the seat moves, all the presets change, all the stuff that we can store, and it gets switched. If you have a whole bunch, you click on a person, so it's Elon, you may have heard of him. Seat starts moving. Elon's pretty tall, so it's sliding back in my case. Now if I go into the driver profile management screen, which is way deeper, you go to controls and then you go to settings, so it's a pretty deep thing. You don't need to interact with it very often. You generally just set it up once. So we have this, what layers do things need to be in terms of hidden in the UI. Things under controls are stuff you need to do while you're driving right in your face. Things under settings are generally stuff that you just set up once. So adding a new driver. I click on the Create Profile button, or I click on the Add a New Driver, and a new driver appears. I can name them, and I can associate it with a key. And I can also save or restore the seating position while I'm editing it. So I type Joe. And here I click on Add a New Driver, and I'm adding yet another driver. And now the current driver is Kevin. He was another guy on the design team, you may guess. Actually, he's a really good visual designer that did the 3D layouts for this stuff. And I can associate a particular key with this driver profile. And the concept there, and I don't know that this is in the car yet or will be, but each key has an ID obviously inside the car, and the car knows which key it is. So you can associate a profile. If you walk up to the car with your key, it'll go to your position with all your stuff. If you go up with your wife's key, it's their stuff. You can still switch drivers, but it's sort of a default. Adding a driver named Kevin. Kevin appears, and you can relink to another person. This is all these use cases and corner cases for all the different things people run into that you have to deal with in UX. We just, no code exists at this point, which is the important thing. We sort of work through how should this work, what are the weird corner cases. I know a lot of you guys that have to do UI programming would probably love to get a stack of this that's already gone through 15 iterations of how it ought to work before it even gets handed to engineering. Other than the, can you do this? Questions. Is this possible? Is this a big dog or a little dog? Deleting driver profiles. These are all corner cases. There's Elon again. Okay, then we go, I'm going to pop now into the mobile application. So I also got to do all the user experience for the mobile app. The left side of the screen is the original wireframes. The right side is the completed visual design. Went through lots and lots of different iterations. And keep in mind, I also do visual design, but my job was user experience. So we went through a lot of iterations of this. And from a UI graphics perspective, I would kill somebody if they shipped this UI. It needs to look this good, but it doesn't need to look this good when you're having discussions with engineering about feasibility. So that's why wireframes are less fidelity. Anyway, this is the idea that on the home screen, you see an actual render of your car, the way your car looks. If it's currently parked, you can see what addresses it parked at, etc. What's its current state of charge, or is it charging, etc. And all these primary functions are available down at the bottom. So also, if you go into the location or map portion, you can see if the car is driving or if it's parked. In this case, the car is parked, and it puts a pin on a map. It also shows, where you are. So this is the device. This is where your Android phone or your iPhone is, and this is where your car is. And you can choose to either center on you or center on your car and map and satellite data. You can also flash the lights on your car. You can also get directions to your car, and it will give you walking directions if you're within a certain distance versus far away. And this is a parked example. This is the visual design on the right. That's where it's parked. Now, if your car is driving, and this is really cool, this was a sort of a long discussion with engineering. It opens a socket through the socket, not the technical term, that's the vague, like computers talk to each other, please term. Talks to the Tesla servers that have VPN connection to the cars at all time, and opens a channel so it has real-time data to the telemetry of the car. So which direction, what speed, what are the actual pedal inputs in terms of accelerating or regenerating? And you really get a live view of the car. So if someone has stolen your car, you can go into your Tesla app and just let them go. It's fine. Call the cops or go casually follow them behind and not worry if they get out of sight, because you can fully track the car and how fast it's going and everything. It's kind of cool. To my knowledge, this hadn't been done before, but I know a couple other companies picked this up. Here's another piece of the puzzle, was the instrument cluster behind the steering wheel. Some really good visual designers working on that. I think it's one of the most beautiful parts of the car. I'm a math guy, so I really like how it laid out. But the visual designers doing this were not necessarily math people, but I am. So I wanted the sweet spot, visual sweet spot, which is, between 50, 60 miles an hour, to be right in a nice, convenient angle based on how you could see it through the screen. And I wanted it to be a continuous arc that goes all the way up to the maximum speed of the car, but you don't need the resolution sort of fidelity towards those higher speeds, because you're not going to be looking at your instrument cluster. You damn well better not be if you're going that fast. And we also had this big number sitting right in the middle. So there's an actual a nasty equation. I actually needed help from one of our really hardcore science guys to get it, and I obscured it because I don't know if that's something they want ever to get out. But the position of that arc is actually a reducing. It's two curves. It's linear at the bottom, and then it goes into exponential. But the meet point are exactly matching. And same thing on the regen, or on the power consumption versus regen. It can use a heck of a lot of power if you drop the pedal, but this is an exponential curve going up. But there's also an exponential curve going down, but it's a significantly different range. So those also are two curves that perfectly tangentially touch each other. So from the eye's perspective, you know, your peripheral vision when you're driving, the way that sweeps up and sweeps down when you go into regen looks perfectly natural, but it's doing two totally different exponential functions. Anyway, little details. Details matter. I also had the pleasure, I actually did the artwork myself for the steering wheel controls. So that I got to draw that face and draw these buttons and a horn sign and stuff. And that's one of the pieces, actual visual design that I got in the car that I got to do. So last piece, I'm also, if you guys know my background, I've been racing for a lot of years. That's sort of why I have a job so that I can race. And I'm also a racing instructor. So one of the really fun things, this is probably my happiest day at Tesla, is just setting a lap record at Laguna Seca, winning an EV time trial, because I got to do a bunch of the performance testing on the cars as well. It was a side thing. Obviously my job was UI, but I got to do a lot of track stuff, which was really cool. It was a perfect overlap for me. But that is 10 words or less. That is the short version of sort of the design process. There's lots more details, lots more pieces. But I want to open it up to questions. We've got a few minutes left to do that. Anybody have any questions about Tesla Model S or UX design? Go ahead.
The interfaces are pretty rich, right? The nice 3D stuff.
Mm-hmm.
Isn't that bad for when you're driving? Because maybe you'd rather have something that is very stylized, so you can easily see what it is.
Right.
So,
So to summarize the question, I think we probably need to use mics, so this is being recorded, but I'll summarize that. I think I can fairly summarize it by saying, what about driver distraction? Okay. Lots and lots of consideration on that. And we've had a lot of people give feedback on forums and things about, like, that's crazy. Why would you do this stuff in a touchscreen? That's not safe. Invariable, those are people that haven't driven the car yet. So we took a lot of trouble on things you need to actually access as a driver are either available through these roller controls and are in the instrument cluster in a really, really simple way, or by voice command. You also have voice commands on the car. But all the stuff you need to access over here on the right, we've made it as, sorry, Carl just held up. He's showing me where his car is right now. All of the controls you actually need to get out while you're driving, we made very aggressive choices to make sure that they are first level, one button click, as obvious as you possibly can. There is a fully functional web browser that you can go into, and you're not restricted from doing that while you're driving. But that sort of stuff, that's sort of, you're playing at your own risk. The things you need to do while you're driving with driver's discretion are all things that we made as simple as possible. And the cool thing is having this much real estate, it's a huge piece of real estate. All the targets are huge. And also we found that the hit points are way, way taller than what's visually being drawn. So like this control button, might be all the way up to that edge. It counts as a tap on it, all intentional. And all the buttons, sort of this tall, rounded zone that results in a tap, because your hands are bouncing a little bit vertically, but not so much horizontally. And if you're near the edges, we could use tighter resolution or touch resolution, because people are usually bracing a finger or two on there and they don't have as much bounce. So, I mean, the short answer is yes, we thought about that a lot. And I encourage you to go drive a car more than just a quick drive. Like, go drive it for a couple of days. And if there's something that you felt is distracting you, Tesla wants to know about it. I don't work there. Don't tell me. I'll probably just laugh at you. That sucks. But they definitely want to hear about it. But to my knowledge, it's not been an issue. Anybody else? We should probably get on a mic if you want to ask a question for the recording. He says, no, I'm just going to raise my hand. Okay, go ahead.
What was the size of this project? So how many people were there in the team?
How big was the team? Shockingly small. I have a history of working in really small teams, which I think are way more effective than large teams. I apologize for anybody from giant companies. When I started on this team, there was one guy. He was a visual designer, very, very good guy from Apple. And I came in as the only UX guy. And during the project, which is just over a year basically doing this, we grew the team to 4 people, 1 UX guy, that's me, and 3 visual design guys. All of us had come from Apple, which is just lucky coincidence, or unlucky if you're an Android person, I guess. But very, very small. So the engineering team was significantly larger, but also very small, very efficient. So yeah, tiny. Good and tiny. Anybody else? In the back. Yes. It's funny because I was going to start with that because I knew that was going to be a question. The question is, what type of UI framework was used here? So again, I wrote exactly 0 lines of code, but I am familiar with it, so I can answer the question. This whole thing is on Linux with a Qt framework, just as a drawing layer, and then everything else is custom. So the whole UI, the whole stack, the network management, the socket controls, all that stuff is all custom code. It's all in C and C++. The majority of the team had come from sort of the embedded automotive software world. And see what else. I'm trying to think of other pieces. There were several plugin modules that were in C and C++, like the navigation system was a C and C++ thing. Oh, the processors are interesting too. So there's 2 Nvidia Tegras. The big screen has sitting behind it a Nvidia Tegra 3 running a 1280 by 1920 resolution display, a 24-bit color. The screen itself is totally custom made, just for Tesla from a vendor with an integrated capacitive touch panel on it. So many iterations of that. We initially started with an array of IR lasers and IR receivers diagonally on the car so that you could use it with gloves on. But the resolution didn't warrant the overhead for that. We ended up going with capacitive touch because at that point everybody was using their phone in the car anyway. And we figured if it's good enough for them, we can simplify our world. There's a the instrument cluster is actually running an Nvidia Tegra 2, which is a little bit lesser processor, but it has less screen real estate to deal with. And the biggest sort of processor hog in terms of memory is the navigation system, which we actually had running on the Tegra 2 and a whole bunch of network communication between the 2 systems with Google Map tiles showing on the bottom right that were just showing GPS waypoints generated by the navigation C++ code on the top. So it's very, very, very complicated and very custom built system. Go ahead here, the white shirt.
What about direct sunlight? With the sunroof up, down?
Oh yeah. So the question of direct sunlight on this, again, I'd say go try the car. Lots of iterations on the coding on the screen. I'm not really qualified to comment too much on it. I just know that we saw a whole bunch of different ones. Also, the sunroof, the cars that come with the sunroof, it is the most they say, first of all, it's the largest sunroof opening of any production car ever. But it's also the best UV protection of every major sunroof, or yeah, whatever you call it, sunroof cover ever. So the incident light from the top is a lot less than people thought. In my testing the car, there was only a couple instances where it felt like it was over-glared. But we also have a day and a night mode on the car too. And I guess at the very beginning I showed an example of that. Where in day mode, everything switches to a really, really bright color. And the brightness of the display is dynamic based on ambient light too. So generally non-issue, but I'm sure there's cases where it's hard to see. Just we didn't run into that very much at all. Okay, way in the back.
Is everything standard or do you have optional features?
Is everything standard or optional features? Again, not totally qualified to answer. When I left the company, we were shipping the Signature Series car, which has everything. Everything you could possibly have. And the big reason for that was because engineering hadn't gotten around to breaking things down into packages like that. So I believe now there are features that come and go based on different price points, but I'd look at the website. I honestly don't know. I imagine there's probably, I know there's a tech package that I think includes Nav, et cetera. But now even they added standard in the cars without telling anybody. It has an Autopilot system that is just there. It's, you know, even in the lowest version of the car, it has an Autopilot where you could fall asleep and the car will stay in its lane and actually sees speed limit signs and accelerates and decelerates based on that, and has adaptive braking. You know, don't fall asleep in the car. You can just hit a turn signal and it changes lanes by itself. You know, does all the, I don't know if you guys have seen the videos, but that all just came out recently. All that hardware was in the car for a couple of weeks before they made that announcement, if you had bought a car in that period. And then all of it was enabled by an over-the-air software update, which is pretty damn cool. Any other questions out there? Cool. All right, one more.
When you are planning to release like a kit car from the Night Rider?
Is Tesla, I can't say me, I don't work there anymore, are they building Knight Rider, I think was the question. Of course. Why wouldn't they build Knight Rider? Kit's old though, it's a much better style Knight Rider. Go ahead.
You mentioned that there are certain points that are easier to reach for a driver in terms of UX. Is there any adjustments for version for the UK on the right-hand side driver wheel?
Yeah, so the question is, from a UX perspective, there are certain zones that are easier to reach. And from my understanding, I left before they did the right-hand drive car, but from my understanding, yes, they've swapped stuff around. So the same, you know, I believe that control button is in the bottom right-hand corner. I think those are swapped. Because like this is a passenger volume control, because you have a volume control on the steering wheel as well. Anybody else? Okay, I think last question. We only have a couple more minutes.
Now we have the new Apple and Android car systems, right? They're coming up. Did you take a look at them as well already?
So
what is the difference? So how do they compare?
yeah, it's a good question. So the question was, what about Apple I Carplay and Android Automotive, which are the two sort of new platforms from the big mobile space players? I mean, I can say the obvious. They totally didn't exist when we did this. But I talk a little bit about them. So Apple I Carplay is, if you think about it, or at least the way it's architected is it's a remote usage interface for your iDevice, you know, your iPhone or your iPad. So you plug that in through a USB, and it allows your deck to sort of surrender control to the iPhone. So the deck itself can be any stack. It doesn't really matter, as long as if they've done the work to integrate I Carplay, then if it goes into that mode, which I'm pretty sure is optional. If you plug in your phone, it says, do you want to go I Carplay? Yes. Click. Boom, the screen pops in. And the phone itself is driving all those functions, and it really is just a remote display with steering control, voice input through all the car, through a standard interface. The Google Automotive thing, by the way, and if you unplug your phone, or if you don't have an iPhone, the deck still has to be fully functional with all of its stuff. So it's not a new plug-in reskinning, effectively. The Android stuff is both. It's a full stack, you know, as an option if you're an OEM provider for a car deck or a car manufacturer. You can use their base and actually, you know, replace what you had with their whole thing. It's a fully working system that you can log into your Google account, and it does all that stuff. And if you plug your phone in, it's, you know, it doesn't necessarily have to take the screen over. The screen's already running Android, etc. I believe, I don't know this is a fact, but I believe there's also a version where you have your own deck, and if you plug in a Google phone, it does similar to what I Carplay does. But primarily, it's a full replacement stack for OEMs to use. And they're both awesome. The point is, though, if you don't have one of those in the car, it still has to be awesome without anything in there. So, okay. And I'm out of time, so thanks for coming. Sorry the other speaker couldn't make it, and I'm glad I was able to fill the time. Cool.